Hello students, welcome to this lecture, some application of trigonometry. Okay, so in this lecture, we will discuss height and distance about this topic, and then we'll discuss some examples. Okay, and let's get started. So in the previous chapter, we have studied about trigonometric ratios and some trigonometric identities, and in this chapter we will be studying about some ways in which trigonometry is used to daily life, okay, around you. So we have seen this type of problem in our introduction of previous chapter, that is introduction to trigonometry. Okay, so in this chapter basically we will study about this type of problem, okay, about heights and distances. So let us consider figure 8.1 here for previous chapter that we have discussed, which is redrawn below in the figure 9.1. So here we drawn this figure. Okay, so let us see this figure. So in this figure here, this is our observer. Suppose here we here there is a student, okay, and he or she is seeing to top of the Qutub Minar. Okay, so in this figure the line AC drawn from the eye of the student to the top of the minar, this is called the line of the sight. Okay, and the student is looking at the top of the minar, then the angle BAC, this angle BAC, this angle is called angle of elevation. Okay, so this angle is called angle of elevation, and from the eyes of student to top of the Qutub Minar, this distance, this line is basically called line of sight. Okay, so formed by the line of the sight with the horizontal, this is called the angle of elevation of the top of the minar from the eye of the student. Okay, so thus the line of sight is the line drawn from the eye of an observer to the point in the object viewed by the observer. Okay, so if there is someone who is observing some object, okay, so here observer, okay, so the line of sight is the line, this line which actually drawn from the eye of an observer to the point in the object viewed by the observer. Okay, so the angle of elevation of the point viewed is angle formed by the line of the sight and horizontal level. Okay, so formed by the line of the sight with the horizontal when the point being viewed is above the horizontal level. That is the case when we raise our head to look at the object. Okay, so this is the case when we raise our head to look at the object. That case, this line is called line of sight, and this is horizontal level. Okay, so and angle of elevation is basically angle between line of sight and horizontal level. Okay, so this is the case when we raise our head and look at to the object. Okay, so now consider the situation given in figure 8.2 that you have studied in your previous chapter. The girl sitting on the balcony is looking down at a flower pot placed on a stair of the temple. In this case, the line of sight is below the horizontal line. Okay, so because since the girl sitting on the balcony, okay, and she is looking down at a flower pot placed on a stair of the temple. Okay, so in this case, the line of sight means the eye, from the eye of the girl to flower pot. This line is called the line of sight. Okay, so in this case the line of sight is below the horizontal level. Okay, so the angle formed by the angle formed by the line of sight with the horizontal is called the angle of depression. Okay, so this angle is this here basically this angle, this type of, you can visualize this picture. So here she is sitting on the balcony of her house. Okay, and she is looking at some pot of the flower pot on the temple basement. Okay, so here she is looking this object, and this is horizontal level, and in this case line of the side is below of the horizontal level. Okay, and the angle formed by the horizontal level and angle of line of sight is basically angle of depression. So this angle is called angle of depression. So the angle of depression of a point when the object being viewed is the angle formed by the line of sight with the horizontal line. Okay, horizontal level when the point is below the horizontal level. That is the case when we lower our head to look at the point being viewed. Okay, so in this case, when we look at lower, that case we get angle of depression. Okay, and angle of depression is formed by the line of sight and the horizontal level. And we have also studied about the angle of elevation. That case the angle for the angle formed by the line of sight and horizontal is called angle of elevation. That case actually we look at the upper we actually that case our head upper our head to look at the object. Okay, so now you may identify the lines of sight and the angles so formed by figure 8.3. Are they angles of elevation or angle of depression? So you can easily now identify the lines of sight and also the angles so formed by the line of sight and the horizontal level. Okay, and what type of angles basically is that you can also identify that. Okay, so are they angles of elevation or angle of depression, that you can identify. Okay, so let us refer to the figure 9.1 again. So if we want to find the height, so I here refer this figure again. Okay, so here AC, this is line of sight. Here AB is horizontal level. Okay, and BC is height of the Qutb Minar. So let us refer this figure, and again if you want to find the height CD of the minar without actually measuring it. Okay, so without measuring it we have to find the height of the Qutb Minar, that is CD. Okay, so what information do you need? So for finding the height CD of the minar, what information do you need? So you would need to know the following. So you would need to know the distance d at which the student is standing from the foot of the minar. Okay, so you need to know the distance from the student from the which from where student is standing from the foot, okay, to the minar. And you need to know the angle of elevation, that is angle BAC. You have to know of the top of the minar, and you also have to know the height A of the student. Okay, so you need to know also height A of the student. So this information will help you to find the height of the Qutb Minar. Okay, that means you can, by using this information, you can find the height CD of the minar. So assuming that the above three conditions are known. Okay, so here we assuming the above three conditions are already known. So how can we determine the height of the minar? So we can determine height of the minar in this way. So in the figure, here's the height of the minar is basically CD. Okay, so in this figure, CD is the height of the minar. So CD is equal to CB plus BD. So here BD is E. Okay, so which is actually the height of the student. Okay, so AE is the height of the student, and here BD is equal to A. So, and here we can write CD, this is equal to CB plus BD. Okay, so to find BC, we will use trigonometric ratios of angle BAC. So if we have given angle of elevation, that is angle BAC or angle A, then to find BC, we will use trigonometric ratios like sin A, cos A, tan A, cot A, cosec A, sec A. Okay, so in triangle ABC, the side BC is the opposite side in relation to the known angle A. And now, which of the trigonometric ratios can you use here? So, which one of them has the two values that we have and the one we need to determine? So, our search narrows down to using either tan A or cot A. Okay, so you can use the trigonometric ratio tan A or cot A. Okay, so as these ratios involve AB and BC. Okay, that is why we can use either tan A or cot A. So therefore we know tan A, this is equal to BC over AB. Okay, that is tan A is equal to BC by AB, or cot A is equal to AB by BC, which one involving would give us BC. Okay, so to find BC, we can use trigonometric ratio either tan A or cot A, because tan A and cot A involves A, B and BC. Okay, so tan A is equal to BC by AB and cot A is equal to AB by BC. So now by adding AE to BC, you will get the height of the minor. Okay, so if we add AE to BC, then you will get height of the minor. So now let us explain the process. So here we'll explain the process how to find the height of the minor. Okay, so we have just discussed by solving some problems. Okay, so here in first example, here we have a tower stands vertically on the ground. Okay, so suppose we have a tower which stands on the ground vertically, and from a point on the ground, on the ground which is 15 meter away from the foot of the tower. Okay, so here this distance point, the distance from B to C is 15 meter. So from a point on the ground which is 15 meter away from the foot of the tower, so angle of elevation of the top of the tower is found to be 60 degrees. So this angle, this angle is basically angle between line of the side and horizontal level. Okay, so this is given to us. The angle of elevation of the top of the tower is found to be 60 degree. Okay, so now we have to find height of the tower. So we need to find this is okay. So we need to find AB, and here AB is basically height of the tower, and we have given the distance from a point on the ground which is 15 meter away from the foot of the tower. Okay, and here we have also given angle of elevation is equal to 60 degree. Okay, and now we have to find height of the tower. So let us solve it. How to solve it? Let us see. So here first let us draw a simple diagram to represent the problem. Okay, so see figure 9.4. So you can see figure 9.4 there, that actually the figure simple diagram of the given situation. Okay, so here AB represent the tower. Here this picture. So here AB is represented height of the tower. BC is represented distance from the from a point on the ground of which is 50 meter away from the foot of the tower. Okay, so this is BC, and line of sight AC. So here AB represents the tower, CB is the distance of the point from the tower, and angle ACB is the angle of elevation that is given to 60 degree. So we need to determine the height of the tower, that is AB. So also ACB is a triangle and right angle at B. Okay, so ACB is a right angle triangle. So to solve the problem, we choose trigonometric ratio tan 60 degree or cot 60 degree. Okay, as the ratio involves AB and BC. That is why we here choose the trigonometry ratio tan 60 degree or cot 60 degree. Okay, so here now tan 60 degree, this is equal to AB by BC, and we know the value of tan 60 degree, that is equal to root 3. Okay, so that is root 3 is equal to AB by BC, and here the length of BC is equal to 15 meter. So here we put the value of BC is equal to 15. So it implies root 3 is equal to AB by 15. Okay, and it implies AB is equal to 15 times root 3. So hence the height of the tower is 15 times root 3 meter. So this is the final answer. Now let us see next example. So in next example we have an electrician has to repair an electric fault on a pole of height 5 meter, and C needs to reach a point 1.3 meter below the top of the pole to undertake the repair work. You can see figure 9.5. So what should be the length of the ladder that C should use, which when inclined at an angle of 60 degree to the horizontal would enable her to reach the required position? So first, how far from the foot of the pole should C place the foot of the ladder? So here you may take the value of root 3 is equal to 1.73. So here basically we have an electrician C has to repair an electric fault on a pole of height 5 meter. So here we have given height of the pole is equal to 5 meter, and C needs to reach a point 1.3 meter below the top of the pole to undertake the repair work. Okay, and what should be the length of the ladder that she should use, which when inclined at angle of 60 degrees. So here we have given angle of elevation is equal to 60 degree. Okay, and would enable her to reach the required position. So and also we have to find how far from the foot of the pole should she place the foot of the ladder. And here we have also give hint you have to take the value of root 3 is equal to 1.73. So let us see how to solve it. So now can you think which trigonometry ratio should we consider here? So it should be sin 60 degree. Okay, so since here sin 60 degree involve BD and BC. Okay, and here we have given the value of BD is equal to 3.7, and here we have to find the value of BC. Okay, so BD by BC, this is equal to sin 60 degree, and this implies 3.7 by BC is equal to root 3 by 2, since sin 60 degree is equal to root 3 by 2. Okay, so therefore BC, this is equal to 3.7 into 2 by root 3, and if we put the value of root 3 is equal to 1.73 that is given to us, then we'll get this is equal to 4.28 meter. Okay, this is our approximation value, 4.28 meter. So BC is equal to 4.28 meter. That is the length of the ladder should be 4.28 meter. Okay, so the length of the ladder should be 4.28 meter. So now DC by BD, this is equal to cot 60 degree, this is equal to 1 by root 3. Okay, and that is DC, this is equal to 3.7 by root 3, and if we put the value of root 3 is equal to 1.73, then we'll get this is equal to 2.14 meter approx value. Okay, so therefore C should place the foot of the ladder at a distance of 2.14 meter from the pole. Okay, so therefore the length of the ladder should be 4.28 meter, and C should place the foot of the ladder at a distance of 2.14 meter from the pole. Okay, and now let us see another example. So in this example here we have an observer 1.5 meter tall is 28.5 meter away from a chimney. Okay, so the angle of elevation of the top of the chimney from her eyes is 45 degree. So what is the height of the chimney? So here we have to find the height of the chimney. Okay, and here we have given an observer 1.5 meter tall, and and she is 28.5 meter out from the chimney, and the angle of elevation of the top of the chimney from her eyes is 45 degree. That is given to us, and here we have to find what is the height of the chimney. Okay, so let us solve it. How to solve it? Let us see. So here you can draw this diagram. So here this is our chimney. Okay, so this is our chimney, and here she's standing. Okay, so now here we have given the angle of elevation, that is equal to 45 degree, and here we have given the value of BE. We have given the height of her is equal to 1.5 meter. Okay, so we have given this, and here AB is the chimney. So here the height of the chimney is AB. So and CD the observer. So CD the observer here, and angle ADE, this angle, the angle of the elevation. See this figure. Okay, so in this case ADE, this triangle is a triangle, right angle at E, and we are required to find the height of the chimney. Okay, so here we have AB height of the chimney. This is actually equal to AE plus BE. Okay, and here we have given the height of the observer. So height of the observer is here DC, and that is equal to BE. Okay, so AB, this is equal to AE plus BE, that is equal to AE plus 1.5. So AB is equal to AE plus 1.5, and here DE, this is equal to CB, and this is equal to 28.5 meter given. Okay, so given to us. So here CB this is equal to D, and this is given to us 28.5 meter. So to determine AE, we choose a trigonometric ratio which involves both AE and DE. So let us choose the tangent of the angle of elevation. So here we choose tangent trigonometric ratio. So now tan 45 degree, this is equal to AE by D. Okay, so tan 45 degree, this is equal to AE by D. And here we know the value of D is equal to 28.5 meter, and we also know the value of tan 45 degree, that is equal to 1. Okay, so it implies to us that is 1 equal to AE by 28.5, and therefore AE, this is equal to 28.5, and now the height of the chimney, that is AB, and this is equal to AE plus height of the chimney AE plus B. So here we found the value of A is equal to 28.5, and we know the value of B, that is equal to 1.5 meter. Okay, so the height of the chimney, this is equal to 28.5 plus 1.5 meter, and this is equal to 30 meter. Okay, so the height of the chimney is equal to 30 meter. And now let us see next example. So in next example, here we have from a point P, on the ground, the angle of elevation of the top of a 10-meter tall building is 30 degree. Okay, and a flag is hoisted at the top of the building, and the angle of elevation of the top of the flagstaff from P is 45 degree. So find the length of the flagstaff and the distance of the building from the point P. So here you may take root 3 is equal to 1.732. Okay, so here basically we have a point. So here we have given from a point P, on the ground, the angle of elevation of the top of a 10-meter tall building is 30 degree. Okay, and a flag is hoisted at the top of the building, and the angle of elevation of the top of the flagstaff from P point is 45 degree. And here we basically have to find the length of the flagstaff and the distance of the building from the point P. Okay, so let us see how to solve it. So here you can see this figure. So here this is our building, okay, and this is our flagstaff. So and from this point it is observing. So angle of elevation of seeing this, okay, so this angle is given 30 degree and this angle is 45 degree. Okay, so now in figure 9.7, here AB basically denotes, AB denotes height of the building, and BD denotes the flag step, and P the given point. Okay, and here note that there are two right triangles. They are PAB, this triangle, and PAD. So we have two right triangles. So we are required to find the length of the flag stop. That means we need to find the length of BD. Okay, so that is DB, and the distance of the building from the point P, that is PA. Okay, so we need to find PA and also DB. So since we know the height of the building AB, okay, so we will first consider the right triangle PAP. So here we consider this triangle, and from this right angle we consider the trigonometry ratio tan. Okay, so tan 30 degree, this is equal to AB by AP, and here we have given the height of the building is equal to 10. Okay, so that is 1 by root 3 is equal to 10 by AP. Okay, and therefore AP is equal to 10 root 3. So here AP is equal to 10 root 3. AP is equal to 10 root 3. That means the distance of the building from the point P is equal to 10 times root 3. Okay, so that is the distance of the building from point P is 10 times root 3 meter, and here we may take the value of root 3 is equal to 1.732. Okay, and if we take, then you will get approximately 17.32 meter. Okay, and now next let us suppose DV, this is equal to x meter. Okay, and here AD, this is basically equal to 10 plus x. AD is basically the height of the building plus height of the flag step. Okay, so AD, this is equal to 10 plus x meter. So now in right triangle PAD, here we use the trigonometry tan also. Here tan 45 degree, this is equal to AD by AP, and here AD is basically 10 plus x, and AP is equal to 10 times root 3, and we know the value of tan 45 degree, that is equal to 1. Okay, so now if we put all these values, then we will get, therefore 1 is equal to 10 plus x by 10 times root 3. Okay, that is x is equal to 10 times root 3 minus 1, and if we put the value of if we take the value of root 3 is equal to 1.732, then we will get this is equal to 7.32. Okay, so the length of the flag step is 7.32 meter. Okay, so is this clear to you? So I hope this is clear to all of you. So I move to next example. So in next example, here we have the shadow of a tower standing on a level ground is found to be 40 meter longer when the sun's altitude is 30 degree and then when it is 60 degree. Okay, so here find the height of the tower. So basically here we have the shadow of a tower that is standing on a level ground is found to be 40 meter longer when the sun's altitude is 30 degree, and then when it is 60 degree, find the height of the tower. Okay, so let us see how to find the height of the tower. Okay, so here in this figure 9.8, AB is the tower, that means AB is the height of the tower, and BC, this is the length of the shadow when the sun's altitude is 60 degree, when this angle is 60 degree, and that is the angle elevation of the top of the tower from the tip of the tip of the shadow is 60 degree, and here DB and here DB, this is the length of the shadow when the angle of elevation is 30 degree. Okay, so now let AB this is be h meter and BC this is x meter. Okay, so according to the question, so DB is 40 meter longer, so longer than BC. Okay, so then DB is equal to 40 plus x meter. Okay, so now we have to we have two right triangles, ABC and ABD. And here we use triangle ABC. So from triangle ABC, here tan 60 degrees is equal to AB by BC, or root 3 is equal to H by X. Okay, and naming this equation number 1. So this is naming equation number 1. And in triangle ABD, here tan 30 degrees this is equal to AB by BD. Okay, and it implies 1 by root 3 this is equal to H by X plus 40, and naming this equation number 2. Okay, so now from equation 1, here we have H equal to X times root 3, and putting this value in equation number 2, then we get X times root 3 is equal to X plus 40, and that is 3X is equal to X plus 40. Okay, so 3X is equal to X plus 40, and it implies 2X is equal to 40, and it implies X is equal to 20. Okay, so the height H is equal to 20 times root 3 from equation 1. So therefore the height of the tower is 20 times root 3 meter. Okay, so I stop here this lecture. Thank you very much to all of you.